Hello everybody, this is John, your nudist teacher. Well, I say nudist because, well, you have no idea what I could be wearing. It's all on the computer screen. Well, this is our math playdate. We're going to take an equation and just kind of play with it in a math way. Just, be comfortable with it. Not exactly a Bob Ross moment, but maybe something close. Let's see. Okay, what I'm going to do is take an equation we should all be familiar with from school. We've seen it at least once somewhere. Alright, and I would remind you this is an equation because, well, it's equal to something. It could be 0, it could be y, it could be anything. But if we say it's equal, it's an equation. Okay, let's factor this puppy. X plus 1, x plus 1. You may have several different techniques with which you use to factor things, but I've seen this a bunch of times, so I just happen to know that there are two x1s in here. But I want you to be comfortable with this. So we're going to use a method to check it. I'm going to try and teach you all the different ways there are to check your work without looking at a, equation index or the back of the book sort of thing. FOIL's a method how you check this. First, outer, inner, last. Here's the first two terms, x squared, plus the outer two terms, the x and the 1, 1x. Then the inner two terms, the 1 and the x. And the last two terms in each parentheses. 1 squared equals 0. Okay, you can already see that these two terms give us the 2x up above. So we don't really have to go through that now, do we? Okay. Let us look at what this looks like written in another form. You may have even seen it written this way. X plus 1 squared equals 0. You can actually use that in a shortened form. I'll do another video where we look at some of the algebra tricks. But let's just look at this for now, and we're going to solve for x. Let's simplify it. That's kind of why we're doing this. We're looking for zeros. I should probably put that down. For zeros. Alright, that's probably the first time you've ever seen that spelled correctly too. Alright, so square root x plus 1 squared. What you do to one side, you have to do to the other side, no matter how silly that may look. So we know that's 0. So we're going to say that these two things cancel, the x squared, or the squared term and the square root. That's not always true. Remember that the square root of something is talking about the absolute value of something. So there's a plus and minus term that would be involved here. But to a 0, who gives a care what's plus or minus? We can ignore that, and we can just kind of gloss over that little piece of math. And so we will say, oops, sorry, didn't mean to pull out the color wheel there. X plus 1 equals 0. And then we solve for x. So bringing 1 to the other side, we get negative 1. So that's our 0. Alright, what does our 0 mean? 0 is where a waveform touches the x-axis. It touches it here, it touches it here, maybe that's just a little further. Parabola, for example, which this is of that class, looks something like this, right? Goes forever in either direction, dips down and touches the axis, in this case, in one place. Right? This is just a generic parabola. Touches it in one place. It may touch it in more if we had, a higher x power term, but we don't in this case. Oh, we know that it faces up. How? Well, look up at the very first term, the x squared term, the highest powered term. What sign is it? It's positive. If it was some other sign, it was minus, it'd point the other way. Very easy way to look at that. Okay, now I'm going to try a trick with this. This is my first video using this tablet, and you can do some really cool things with it. I'm going to try shrinking this stuff. And, let's see. Oh, I know I need to hit this one. Okay. Different icon. Alright, so I'm going to shrink it. Ooh, look at that. Now it doesn't take up quite so much space. This is kind of like those big college classrooms where they have the multiple boards where you can just slide them up and down. So we can kind of do it too, that's just awesome. I like that. Okay, so we're going to draw a generic picture of our graph. We know it's parabola, we know it faces up, we know it touches the graph at most one place. I like to label my graphs. I'm not too good at art, so don't criticize. I really don't want to hear it. Okay, so always label all the parts of your graph. You got the y-axis, you got x-axis, you got 0 points. There's our -1. Okay, we'll switch colors here. And we know it touches right here at -1 on the x-axis, where y is equal to 0. How do I know y is equal to 0? Right there. Y is equal to some equation, right? The equation is over on the other side. So we know that when y is equal to 0, and that is the case for the entire x-axis, y is equal to 0 here. We know that it opens up. So we know one of the branches goes up like that. Where does the other one go? How far up can I draw it? Does it touch the y-axis? Okay, let's remember the y-axis is also where x equals 0. Okay, that's a major hint right there. So, what we do is we take the equation, the original equation we had, remember it was this? Oh, I should probably do that in the first color. Okay. What am I doing? X-axis. Okay. So we write down the original equation again. And this time we say it's equal to y. And we're evaluating it at y equals 0. That's this bit right here. Because y, this equation back here, remember that's really y. Okay? We're finding all the values of y. Y is equal to 0 at some point. And that's where it touches the y-axis. Have I confused you enough yet? Well, let's just run through it. So, this little point here that we're talking about, in the parentheses, the point 0, is going to be substituted everywhere where we see an x. 0 squared plus 2 times 0 plus 1 equals this y evaluated at 0. Get used to saying that. So that's really how we do things in math. Okay, that's a 0 term. That's a 0 term. The only thing that survives is this little bit right here. So, y is equal to 1. Y evaluated at 0 is equal to 1. That is where it touches the y-axis. And I'm going to, let me try this other color. Okay, right there. Look at the graph. And it bounds right through that point. That's where it touches. So now we've got sort of a well-drawn graph of that equation. We know exactly what it looks like. We know where its 0 points are. Remember, they're also called roots. That's where the root of this one equation is. Now, question of the day. What happens if this term right here is negative? I'll leave that for you to discover. And we'll see you on the next Math Playdate. Hope you had fun.